Now, let's start with the PSV inlet and outlet lines. As we see, the PSV is set to open at a specific pressure. This pressure is sensed from the PSV itself, which means that we are talking about the pressure here at the PSV inlet. Now, when the PSV opens, the flow starts to pass from the system to the PSV. As the flow passes through this line, some pressure drop occurs. What if the pressure drop here was significant, such that the PSV is sensing a lower pressure than the set pressure? In this case, the PSV shall read a pressure which is significantly less than its set pressure. So it shall start to close again, although the pressure in our system is already at the set pressure. This shall cause the pressure even to rise more until the PSV senses the set pressure again, as there is no flow and hence no pressure drop at the PSV inlet. So the PSV starts to reopen again, and once the full relief load passes and pressure drop is significant again, the PSV shall start to reclose. This phenomenon is called PSV shattering, and it can cause damage to the PSV on the long run. That's why API 520 recommends that the pressure drop in the inlet PSV shouldn't exceed 3% of the set pressure. That's why we should choose a pipe size that shall achieve this requirement. And if we choose a smaller pipe size, this shall lead to shattering. If you like to know more about the pipe sizing and how to achieve the required sizing criteria, I have talked in detail about pipe sizing in the hydraulics 4-in-1 course. You can check it out in the bonus lecture if you like. In addition, any isolation valves shall be full bore valves. So this is to reduce the pressure drop through the valves as much as possible. Something else would be considered when designing the PSV inlet. We should ensure that there shall be no entrainment from the upstream system. If the relief gas flows with a high velocity, it may be accompanied with some liquid droplets, and we should reduce these droplets as much as possible. This is because entrained liquid can lead to a high pressure drop and a two-phase flow regime which shall cause disturbance in the system. That's why it's highly important to consider a slope in the PSV inlet line which shall drain the liquid back to the vessel. In addition, there shall be no pockets in the PSV inlet line, as the collected liquid can totally hinder the PSV relief job and won't prevent overpressure from occurring.